Now, as we have already talked about the main fertilizers that we have and the main characteristics of those fertilizers, we're going to review some characteristics of a program called FertiliCalc, which is a decision support system for fertilizer management. And this program, which is intended to help different users in deciding what are the amounts of phosphorus, potassium, and nitrogen to apply to their crops, has had a lot of contributors. First, the co-authors of the chapters in the book, Professor Miguel Quemada from Agrónomos in Madrid, Professor Antonio Delgado from Agrónomos in Córdoba, and my colleagues in Córdoba, Professor Álvaro López Bernal, and Doctors Francisco Orgaz and Luca Testi. And also for producing versions for different languages, we have had the help of more than 60 agronomists from different universities and different agricultural colleges and universities specialized in soil science or agricultural chemistry. FertiliCalc was designed first to help in our class of Principles of Agronomy for Sustainable Agriculture. So it was first thought as a tool that would help the students to understand better the calculations related to fertilizer amounts. But then, as the program developed, we believe that the program might be useful for other users like agronomists in the private sector, extension officers, advanced farmers directly, or fertilizer manufacturers if they want to analyze how much different products or how different products can adapt to different crops. The main features of the program are, first, that it allows the calculation of amounts of fertilizers for giving the requirements for nitrogen, phosphorus, and potassium. It is free and non-commercial, so it is free for everybody to download. It's completely publicly available for everybody. It includes an extended list of crops. This moment it has 149. We have reached 69 translations to different languages, and it provides the calculation of nitrogen losses and also of acidification. In general, although we have not emphasized that idea, but in general, another important difference between using nitrate and ammonium fertilizers is that ammonium fertilizers produce acidification of the soil, while nitrate fertilizers do not produce acidification. FertiliCalc, apart from calculating the amounts of nitrogen, phosphorus, and potassium fertilizers, also allows or estimates the balance of calcium, magnesium, and sulfur, so we can evaluate if the amount, if the fertilizer products that we are using and the amounts that we are using are causing any deficit of these elements. To download the FertiliCalc, we need to go to this web page. Well, this is the web page, uco.s/phytotechnia. Then you have a link to fertilicalc.html. And in this, we have the different versions for different languages, and we have also access to tutorials in English and in Spanish, and we have also short tutorials. They are mute for different languages. And so this is only to show how the program is used with very basic ideas. In this web page, you have also access to a paper published on FertiliCalc, and also we have published paper in Spanish that you can download here. And also, if you are fond of programming, you can download the code of the first part of the program in the Python language. Okay, once you have the program and you run it, you will see first page like this one, where you see the list of different crops. You select the crops that you want in your crop rotation. You can add here as many crops to your rotation as you want. In this case, in this example, I have added a sunflower crop and a wheat crop. And you have always to put here what is your yield. When you put the yield, you also need to indicate if you are going to burn the residues. These are the values that have already in the database, but you can always edit these values. For instance, for sunflower, it has 35% for harvest index, and for wheat, it has 40. We can change these values. We can change also the percent of residues left in the field. In this case, we say that only 10% of the residues are left in the field for wheat. This means that we are selling this wheat straw as fodder for other farms. So this is a minimum amount that is left in the field. In the case of the sunflower, 100% of the residues are left in the field. Then, in the lower part, we have to select the soil type. In this case, it is a clay loam, which has been selected. And if we have data on this, we have a soil analysis with the concentration of phosphorus or potassium, soil organic matter, we would include the data here. The program will automatically select a value for cation exchange capacity according to the soil texture. In this case, it has assigned 220. And we have also a value of pH. We can always change these values if we have soil analytical data. If we are working in another country, maybe the analysis is not the Olsen for phosphorus, as in this case, and we can select different other analyses that are used in other countries of the world. Then we decide what is the strategy for phosphorus and potassium fertilization. Remember, the build-up and maintenance was the most general case. Build-up and maintenance means that if the soil analysis is very low, we need to add more than the crop exports. And we have here two possibilities: reduce fertilizer or maximum yield. Reduce fertilizer will use the lowest value possible within the uncertainties of the program. And for maximum yield, we would use the higher values of the parameters. But in both cases, we try to build up the concentration if the concentration is too low. And also, we will return the exports of nutrients from the farm. If we don't have soil data, we can only use the maintenance alternative. Maintenance means that we will add nutrients to compensate exactly the exports of nutrients from the farm. There was another with the sufficiency strategy. This strategy is only for conditions where we want to save money with the fertilizers, but for that we need to have data on soil analysis, and we will only apply fertilizers if the concentrations are below the critical level. We also indicate if we are applying tillage, and we also indicate if we are applying water, or if we are in a humid environment, or otherwise if we are in rain-fed conditions or arid conditions. Once we have filled this data, we click on proceed and go to the second page, where we see already the calculations by the program of the amounts of nitrogen, phosphorus, and potassium, assuming zero losses. These are the fertilizer requirements that assume zero loss. Then we will have to supply these amounts using different fertilizers. And for that, we see here, first, we see a straight nitrogen fertilizers: sodium nitrate, calcium nitrate, magnesium nitrate, ammonium sulfate, urea, calcium cyanamide, etc. Then we have a straight phosphorus fertilizers: superphosphate, triple superphosphate, dicalcium sulfate, etc. Then we have a straight potassium fertilizers. Then we start with binary monoammonium phosphate, diammonium phosphate, ammonium polyphosphates, and this would be potassium nitrate, that is a binary Kn. We also have organic fertilizers. For instance, the manure from swine, from beef, from dairy, etc. In this list, we add here as many fertilizers as we want. In this case, we have added one for nitrate, for nitrogen, urea, triple superphosphate for supplying phosphorus, and potassium sulfate for supplying potassium. See also that this potassium sulfate has also sulfur. See also that triple superphosphate has a disadvantage over superphosphate. We said that superphosphate has calcium. Triple superphosphate has no calcium at all. And urea is a straight nitrogen fertilizer, so it has only nitrogen. We see here that we have prices for the different fertilizers. We can edit these values. So if our fertilizer dealer gives us a different price, we can put here the price that we want. We can have also to mark if the fertilizers are incorporated or not. That can have important effects on the losses by ammonia volatilization. Once we are done with selecting fertilizers, we click on this box, and then the calculation of the fertilizer amounts will be performed. And then we will see this third screen that shows the calculated amounts of urea for sunflower and wheat, of triple superphosphate and potassium sulfate, and the calculated cost. Well, this you don't have to, it could be euro per hectare or any other monetary unit per hectare. In this case, the calculations are based on euros. So this would be the cost of fertilizer per hectare for the sunflower and for the wheat crop. Here we see the calculated losses of volatilization, denitrification, and leaching, and the total losses in kilograms per hectare. and here expressed in percent over total nitrogen applied. It also calculates the acidification. If it is positive, it means that we have some acidification. Why? Because urea converts to ammonium, and ammonium has an acidification effect in the soil. It also provides, as I said, an evaluation, a calculation of the balance of calcium, magnesium, and sulfur, as you see here. Phosphorus and potassium have zero balance, which means that we are returning the same nutrients that are being exported by the crop. So this is fine. But you see here that we are applying a little excess of sulfur. Why? Because we are applying potassium sulfate. But we see also that we have a slight deficit of calcium and a higher deficit of magnesium. We can always click here and go to the previous screen and change and try different fertilizers to compare with those that we have already tried. After we have tried different products, we can click here and show a TXT file, a text file that will be storing all the calculations that we have made. These are the included in results TXT that is always generated in the same folder that you have the FertiliCalc program in. The program also provides a manual and reading materials, and the reading materials are those chapters of the book that include the fertilization. In other words, has chapters from 23 to 26 of our book. We have also the tutorials available in YouTube. To access the tutorials, you go to the Phytotechnia webpage, and from them you go to the FertiliCalc webpage, and the links to the tutorials are all there.